increase the amount of imagined man-made CO2 going into the atmosphere.
We put an increase in carbon dioxide in them that is 1% per year. It's been 0.49% per year for the last 10 years, 0.42 for the 10 years before that, and 0.43 for the 10 years before that. So the models have twice as much greenhouse warming radiation going in them as is known to be happening. It shouldn't shock you that they predict more warming than is occurring.
Models predict what the temperature might be in 50 or 100 years' time. It is one of their peculiar features that long-range climate forecasts are only proved wrong long after people have forgotten about them. As a result, there is a danger, according to Professor Carl Wunsch, that modelers will be less concerned in producing a forecast that is accurate than one that is interesting.
Even within the scientific community, you see, it's a problem. If I run a complicated model and I do something to it, like melt a lot of ice into the ocean, and nothing happens, it's not likely to get printed. But if I run the same model and I adjust it in such a way that something dramatic happens to the ocean circulation, like the heat transport turns off, it will be published. People say this is very exciting. It will even get picked up by the media. So there is a bias, there's a very powerful bias within the media and within the science community itself toward results which are dramatizable. The Earth freezes over. That's a much more interesting story than saying, well, you know, it fluctuates around. Sometimes the mass flux goes up by 10%, sometimes it goes down by 20%, but eventually it comes back. Well, you know, which would you do a story on? I mean, that's what it's about.
To the untrained eye, computer models look impressive, and they give often wild speculation about the climate the appearance of rigorous science. They also provide an endless source of spectacular stories for the media.
The thing that has amazed me as a lifelong journalist is how the most elementary principles of journalism seem to have been abandoned on this subject.
In fact, the theory of man-made global warming has spawned an entirely new branch of journalism.
You've got a whole new generation of reporters, environmental journalists. Now, if you're an environmental journalist, and if the global warming story goes in the trash can, so does your job. It really is that crude. And the reporting has to get more and more hysterical because there are still, fortunately, a few hardened news editors around who will say, you know, this is what you were saying 5 years ago. Ah, but now it's much, much worse. You know, there's going to be 10 feet of sea level rise by next Tuesday or something. They have to keep on getting shriller and shriller and shriller.
It is now common in the media to lay the blame for every storm or hurricane on global warming. But is there any scientific basis for this?
This is purely propaganda. Every textbook in meteorology is telling you the main source of weather disturbances is the temperature difference between the tropics and the pole. And we're told, in a warmer world, this difference will get less. Now that would tell you you'll have less storminess, you'll have less variability. But for some reason that isn't considered catastrophic. So you're told the opposite.
News reports frequently argue that even a mild increase in global temperature could lead to a catastrophic melting of the polar ice caps. But what does Earth's climate history tell us?
We happen to have temperature records of Greenland that go back thousands of years. Greenland has been much warmer. Just 1,000 years ago, Greenland was warmer than it is today, yet it didn't have a dramatic melting event.
Even if we talk about something like permafrost, a great deal of the permafrost, that icy layer under the forests of Russia, for example, 7,000 or 8,000 years ago melted far more than we're having any evidence about it melting now. So in other words, this is a historical pattern again, but the world didn't come to a crunching halt because of it.
Professor Siunishi Akasofu is head of the International Arctic Research Center in Alaska. The IARC is the world's leading Arctic research institute. Professor Akasofu insists that over time the ice caps are always naturally expanding and contracting.
There are reports from time to time a big chunk of ice break away from the Antarctic continent. Those must have been happening all the time. But because now we have a satellite that can detect those, that's why they become the news.
This data from NASA's meteorological satellites shows the huge natural expansion and contraction of the polar sea ice taking place in the 1990s.
Practically all the TV programs that relate to global warming show big chunk of ice falling from the edge of the glaciers, but people forget that ice is always moving.
News reports frequently show images of ice breaking from the edge of the Arctic. What they don't say is that this is as ordinary an event in the Arctic as falling leaves on an English autumn day.
They ask me, did you see ice falling from the edge of the glaciers? Yes. That's the spring breakup. That's happened every year. Press come to us all the time, you know, I want to see something that the greenhouse disaster. I say there's none.
Alarming television programs raise the fearful prospect of vast tidal waves flooding Britain. But what causes the sea level to change, and how fast does it happen?
Sea level changes over the world in general are governed fundamentally by two factors. What we would call local factors, the relationship of the sea to the land, which often, by the way, is to do with the land rising or falling than anything to do with the sea. But if you're talking about what we call eustatic changes of sea, worldwide changes of sea, that's through the thermal expansion of the oceans, nothing to do with melting ice. And that's an enormously slow and long process.
People say, oh, I see the ocean doing this last year. That means that something changed in the atmosphere last year. And this is not necessarily true at all. In fact, it's actually quite unlikely, because it can take hundreds to thousands of years for the deep ocean to respond to forces and changes that are taking place at the surface.
It is also suggested that even a mild rise in temperature will lead to the spread northward of deadly insect-borne tropical diseases like malaria. But is this true? Professor Paul Reiter of the Pasteur Institute in Paris is recognized as one of the world's leading experts on malaria and other insect-borne diseases. He is a member of the World Health Organization Expert Advisory Committee, was chairman of the American Committee of Medical Entomology of the American Society for Tropical Medicine, and lead author on the health section of the US National Assessment of the Potential Consequences of Climate Variability. As Professor Reiter is eager to point out, mosquitoes thrive in very cold temperatures.
Mosquitoes are not specifically tropical. Most people will realize that in temperate regions there are mosquitoes. In fact, mosquitoes are extremely abundant in the Arctic. The most devastating epidemic of malaria was in the Soviet Union in the 1920s. There were something like 13 million cases a year and something like 600,000 deaths. A tremendous catastrophe that reached up to the Arctic Circle. Archangel had 30,000 cases and about 10,000 deaths. So it's not a tropical disease. Yet these people in the global warming fraternity invent the idea that malaria will move northwards.
Climate scare stories cannot be blamed solely on sloppy or biased journalism. According to Professor Reiter, hysterical alarms have been encouraged by the reports of the United Nations Intergovernmental Panel on Climate Change, or IPCC. On the spread of malaria, the IPCC warns us that
mosquito species that transmit malaria do not usually survive where the mean winter temperature drops below 16 to 18 degrees Celsius.
According to Professor Reiter, this is clearly untrue.
I was horrified to read the second and the third assessment reports because there was so much misinformation